Till now, we have learned how to write Python programs using variables, conditions, loops, and functions. But when programs start becoming larger and more complex, we need a better way to organize our code professionally. Okay, that is where OOPS, that is object-oriented programming, comes in. In this video series, we'll understand how to structure our code using classes and objects, how real-world entities can be printed in Python, and why object-oriented programming is one of the most important concepts for building scalable and maintainable applications, right? So in this chapter, we are not just going to learn syntax, we'll build real conceptual clarity on OOPS in Python step by step. So let's get started. What is that is object-oriented programming. Okay, it is a programming approach where we write program by organizing code around objects. Okay, just remember objects rather than only writing a list of instructions. It is a programming style in which we organize code using object and classes. Just remember object and classes. Okay. Now see what happened when we have started our Python programming. Then what we have started with, that is called procedural code. Okay, that is what procedural. That is called procedural code. In procedural code, what happened? We just initiate one variable a equal to 1, b equal to 2. Okay, now we perform add equal to a plus b, then print add. So it gives me the result as 3, right? Again, if we want to perform another addition, then we have to initialize one variable like x equal to 5, y equal to 10. Then we need to perform add equal to x plus y, print add, right? Then we get the output as 15. Okay. Once we have learned all this procedural code, then we move to function based code. Okay, function based code. Okay, so why we have used function based code? To simplify our entire code, we have used function based code. In function based code, what happened? We just create a block of code. This block of code. Okay, and we just reused our block of code anywhere. Okay, anywhere, wherever it is required, right? And it basically helps us to reduce redundancy. Okay, redundancy. So we have created a block of code. That code we can reuse anywhere. Okay, and it basically helps us to reduce our redundancy in our code. Okay, so if we simplify or convert this code in function based code, then what can we do? We just write def, suppose add. Okay, and here we pass two parameters, that is x and y. Okay, then we can perform print x plus y, and when we call our function add and we pass our value 1, 2, then automatically it gives the output as 3. Again, if we need to perform another addition, then just we need to call our function and put my own value like 5, 10, and it gives me the output as 15. If we want to perform another addition, then 10, 2, then it gives me the output as 12, like this, right? So basically, to simplify our procedural code, we have used functional based code, right? So when our code gets bigger, then to simplify our code and to reduce the redundancy, we have used function based code, right? Till now, we have learned all of these things, right? Now, when we move to a advanced level of programming, like when we create any real world software like banking system or software, okay, software or student management system, okay, management system, like this, these all are real world software. Okay, when we move to develop our real world software, then we have to use OOPS concept, where we work with classes and objects. Okay, now try to understand what is classes and what is object, and how class and object works in object oriented programming. Okay, Now let's suppose we are a car manufacturing company. Okay, car manufacturing company. Okay, now we have to create multiple cars. Okay, we have to create multiple cars and we have to store all the data. So for example, now there is two options. One is manual. Okay, now for example, we have to write car name. Okay, car name, suppose car 1, car color, suppose red. Okay, car behavior, it can start. Okay, it can stop, it can accelerate. Okay, like this. Again, another car we need to create. So for that, you have to write car name equal to car 2, right? Car color equal to suppose black. Car behavior, it can start, it can stop. Okay, it can accelerate like this, right? So now think we have to create 500 car like this. Okay, so is this possible to create manually these 500 of cars? No, it's not possible, right? So for that, what we have to do? We have to create a blueprint. Blueprint. Okay. Blueprint. We have to create a blueprint of a car. Suppose this is my blueprint. Okay. This is my blueprint. Blueprint means all the common features that a car should have. Okay. For example, car should have name, car should have color. Okay. Car should have version and so on. Okay. Car should have, car should start. Basically, these are the properties. These are the properties that car should have, and these are the behavior that car should have. Okay. It can start, it can stop. Okay. It can accelerate like this. Okay. So we have created a simple blueprint of a car that all the cars should have all these common things. Okay. Now, once our car is, once our blueprint is ready, then using this blueprint, what we can do, we can create one car, that is suppose car 1. Okay. Now this car has its own name, suppose A. Okay. Car 1 name. Okay. Now car 1 color, suppose red. Okay. Car 1 behavior, it can start, stop, accelerate. Right. Now again we can create another car, that is car 2, and it has all the same features, right? Car 2 dot name, car 2 name equal to B. Okay. Car 2 color might be black. Okay. Car 2 behavior, it can start, it can stop, it can accelerate. Okay. And so on, we can create any number of car. Okay. Car 3, car 4, car 5, like this, right? That means we have created our blueprint once. Okay. But and using this blueprint, we are creating multiple car, which has all the same feature that we have in your blueprint, right? So whenever we need to create a new car, we just copy all the blueprints and create a new car. Right? So using this blueprint, we can create multiple of car. So in programming language, this blueprint called class. Okay. And this car is object. Okay. That means whatever blueprint we are creating for our software, that is class. And using this class, we are creating our object. That means object is instance of a class. Okay. That means we are creating our class once, and using this class, we are creating our multiple object one by one. Okay. So instead of writing all these codes again and again, we just simplify our code and created our one blueprint. Okay, one blueprint, that is class. And using this class, we create our multiple object, and those object is having all the properties and behavior that this blueprint has. Okay. So this entire system makes our code simple and make it more organized, right? This is why we need to use object-oriented programming. Okay. Now, if we see the definition of class and object, a class is a blueprint, design, or template used to create objects. Okay. It defines what data an object will have and what behavior an object will perform. That means this entire blueprint that we have created, that is basically our class. And this class defines all the features and behavior that all the object that is created from this class should have. Okay. What is an object? An object is a real instance created from a class. That means from this blueprint, we have created this car 1, car 2, all these things. So from this class, whatever object, whatever car we have created, that is object. But that means object is a instance of a class. Okay. If class is the blueprint, the object is the actual thing made from the blueprint. So basically, this entire blueprint is our class, and all the cars that is created from this class is our object, right? So all the cars are my object. So I hope you understand what is class and object in object-oriented programming. Okay. Benefits of object-oriented programming. One is code reusability. Write class 1 and create many blocks. So we have already seen we are creating class our once and we are creating multiple objects from this, right? So this is called code reusability. Better organization, related data and method can remain together. Okay. Easier maintenance, scalability, real world modeling. So these are the benefits for object-oriented programming. Okay. So I'm creating a new file. Okay. Oops.py. Okay. Now I'm creating my first class. Okay. Now always remember the syntax of class. Okay. Always you have to start your class with a keyword that is class. Okay. And you have to provide your class name over here. Okay. This is the basic syntax. Okay. Always remember, whenever you are providing your class name, that name has to be started with capital letter. Okay. So this is my syntax. Now I'm creating my new class. Okay. So I have to provide my keyword that is class. Now I'm creating one student class. Okay. Now I'm providing this class name as student and I have given S in capital letter. Okay. Now for the time being, I'm not mentioning anything in my class. Okay. I'm just putting the pass. Okay. Now my class is ready. Now once my class is ready, then we have to create our object, right? So suppose I'm giving one object name that is S1. Okay. And to create my object, we have to call my class. Okay. We have to call my class and we have to put parentheses. Okay. Always remember, whenever you are creating your object by calling your class, you have to put this parenthesis. Okay. If you don't pass this parenthesis, then it will show error. Okay. So you have to put this parenthesis. Okay. Now this S1 is your object. Okay. In the same way, you can create multiple objects. Okay. You can create multiple objects like this. Student, and I'm putting my parentheses. Okay. Now I can print S1, I can print S2 and so on. Okay. Now if I execute this one, now see, student object at this is the position ID and student, and this is for S2, student object at this location. Okay. That means this is for S1, this is for S2. Okay. This is the location ID. Okay. So this is how we can create our class, and using this class we can create any number of object. Okay. Fine. Now let's add some attribute to my object. Attributes means all the features that I have already shown you. Okay. All the objects have its own features, behaviors, right? So these are attributes. So let's add some attributes to my object. Okay. So for S1, first this is S1. Okay. S1. So this student should have name. So we can provide S1.name. Okay. Suppose this is Sam. Okay. Now this student should have marks. Okay. Suppose 85. In the same way, this student S2, this S2 should have its own name, right? suppose allies. Okay, and this student should have marks, so I can provide k marks, right? So now as I have used this attribute, so I can call all the attributes using its object, okay, to print. Okay, now I'm calling this s1.name, okay, s1.name. And in the same way, I can print s1.marks, okay, s1.marks. In the same way, I can write s2.name, okay, and I can print s2.marks, okay. Now if I execute, now see, first one is Sam 85, the s1.name is Sam, s1.marks is 85, s2.name is allies, and s2.marks is 75. Okay, you understand? So we have created our class. Using the class, we have created our object, that is s1 and s2. Now each object has its own attributes, that is name, marks, okay, and then we are printing, we are accessing all the attributes individually, okay, and we are printing all these things, right? That means we have created our class once. That means our class is same, and using this class we are creating different objects, okay, and each object has its different values, okay. This is called multiple objects with different data, okay. So next is method, okay. Method. What is method? See, a class doesn't only store data, okay, it can also define behavior using function, okay. And always remember, method is a function, but we can, whenever we write any kind of function individually, then it is called function. But whenever we write any kind of function inside a class, then that function called method, okay. So method and function both are same, only difference is function is individual, but whenever we are writing any kind of function inside a class, that is called method, okay. These are basic difference. So let me comment it out. Okay, now I'm creating one class, okay, class student, okay. Now previously I put pass, right? That means I did not mention anything inside my class, okay. Now I'm mentioning one method, that is function, okay. Now I'm creating one function, that is def, suppose so, okay. Now here I'm mentioning just print, okay. This is student object, okay. I'm just giving a print statement inside my method, okay. Now once my class is ready, then I have to create my object, that is s1, okay, and I have to call my class, okay. Now as this method belongs to this student class, and this s1 object is instance of this student class, right? So we can call our method like this, s1.show, okay. Understand? This is our class student, and inside this class we are creating one method, okay, that is show, okay. Now using this class I am creating my object, okay, s1, and as this method belongs to this same class, so we can call this method using this object, s1.show, okay. Now see, now if I execute, now it will show some error. Now see, okay, it is showing error. Student.show takes 0 positional argument, but 1 was given, okay. I tell you why. Always remember, whenever we create any kind of method, we have to provide one positional argument, that is self, okay. This is fixed. Whenever you create any kind of method, you have to provide self. Why? Because self refers the current object, okay. Always remember, self refers to the current object. So whenever we execute this code, Python send this s1, this object, okay. Python send this object to this self. Yes, Python automatically send this s1 to the self, and this show will be executed. So always remember, self represent the current object, okay. Now if I execute this one, now see, it is executing, okay. This is student object, it is giving me the right output, right. Now if I put some data in my object, suppose s1 dot name equal to Sam, s1 dot marks equal to 85. Okay. Now one way is like this, we can print s1 dot name, s1 dot name, s1 dot marks, right? But as we are calling my method, we are printing everything using my method. Okay. So we have to mention everything inside my method. Okay. So instead of writing this, what we can do? We can print name. Okay. And to print our name, we have to write self dot name. Okay. In the same way, to print the marks, we have to write marks, that is self dot marks. Okay. Now try to understand what is happening. When I'm executing this code, what happens? Python send this s1 to this cell. Okay. So basically this is s1. Now this becomes s1 dot name. Okay. That means it becomes my output is same, and this become self means s1 dot marks, that become 85. That means using cell we refer the current object, right? At the same time, using self helps each object work with its own data. Okay. That is why whenever Python send this object s1 to this cell, okay, automatically this cell, that is s1 dot name, gets stored. That is here Sam gets stored because s1 dot name is Sam. So here Sam gets stored, and here Sam self dot marks, that is s1 dot marks, that is 85 gets stored over here. Okay. So self refer this kind object, that is s1, and it also helps to use the object, that is s1, to use its own data. Okay. Now if I execute this one, now see, my output is name as Sam, okay, and marks as 85. Okay. So whenever we execute this one, Python automatically send this s1 to this self, and this self dot name, that becomes s1 dot name, and this s1 dot name Sam gets stored over here, and this self dot mark, that becomes s1 dot marks, and here s1 dot mark, that is 85, gets stored over here, and it is printing the same thing whatever I mentioned over here. Okay. Name as Sam and marks is 85. Okay. So I hope you understand why we need to mention our self in our method and how self works. Okay. Now if I give another example, okay, suppose I'm creating one class, that is car. Okay. Now here I'm creating one method, that is display. Okay. And always I have to mention my self parameter by default, right? Now I'm printing the brand of the car. Okay. Brand. And here I have to mention self dot brand. Okay. And another, I want to print color of the car. Okay. Color. And here I have to mention self dot color. Right. Now my class is ready and method is ready. Now I have to create my object. Okay. Now I'm creating one object, that is C1. Okay. And I have to create my object, I have to call my class, right? I have to call my class. Now this C1 becomes my object. Now I'm putting some attributes to my object, that is C1 dot brand. Okay. Now suppose I'm mentioning Honda. Okay. And C1 dot color, suppose black. Okay. Now in order to display my output, I have to call my object and I have to call my method, that is display. Okay. Now if I execute this one, now see, it is giving me output as brand Honda and color black. Right? You understand? So always remember, a class in Python is a blueprint used to create objects, okay? While an object is a real instance of that class. We use classes to define the structure and behavior that similar objects should have, right? Once the class is created, then we can build as many as object we want from it, okay? Each object with different data it can have, okay? This helps us to organize code in a clean and reusable way. Next is, what is a constructor? A constructor is a special method, okay? Always remember, this is a method in a class that runs automatically when an object is created, okay? Suppose we are creating one class, okay? Class student, okay? Now I'm just passing it and I'm creating my object, okay? So these are, we can create our class and object. Now, whenever we are creating my object using my class, here automatically one constructor gets created, okay? And in Python, constructor created by underscore init underscore, okay? In Python, our constructor gets created using this. But if you don't pass anything over here, automatically one constructor gets created once our object gets created, okay? So here I have not created any kind of constructor, but automatically once my s1 gets created, this object gets created, automatically one constructor gets created, okay? Now you might be thinking why we should use our constructor, okay? Now imagine, now this is my object, okay? Now if I add some data over here, now I have to write like this: s1 dot name sam, s1 dot marks 85, okay? Now again I have to write another, if I want to create another student, that is s2 dot name, that is lis, okay? s2 dot marks 75, okay, like this. Then I have to finally print, I have to my print s1 dot name, s1 dot marks, again I have to print s2 dot name, right, and s2 dot marks, okay? Now imagine, if like this, if I want to create multiple student like this, so it is very hectic work, right? This is very hectic work. Now to resolve this case, we have to use our constructor. So what we can do? Now we can write class student, okay? Now we can define our constructor, and constructor is a method. So we can write like this: def underscore init underscore, and here you have to pass my self, okay? And here I can pass my two parameters, that is name and marks, okay? Now I can write self dot name equal to name and self dot marks equal to marks, right? So my class is ready and my constructor is ready. Now I'm creating my object, that is s1, and I'm calling student, and here I can pass my data directly, that is sam and 85. Again I can create my s2 object and I'm calling my student, and here I'm passing my data directly, okay, lis and 75, okay? Now if I write print s1 dot name, s1 dot marks, and here print s2 dot name comma s2 dot marks, then it will give me the same output, right? So instead of writing this code again and again, we're just creating our constructor, and within this we are passing our parameter, okay? And when we are creating our object, we are directly mentioning our data and we are printing it, right? So basically we are simplifying this code using this constructor, okay? So this is the basic advantage of using constructor. Okay, and always remember, whenever we are creating any constructor with only self parameter, then that is called default constructor. And whenever we are passing any kind of parameter, then it is called parameterized constructor. Okay, so just remember this one. In any interview, we may be asked this is okay. What is default constructor and what is parameterized constructor, and what are the differences between them? Okay. Now I'm creating one class. Okay, suppose student. Okay. Now I'm creating my constructor. Def underscore init underscore cell. Okay. Now here I'm just mentioning one print statement, that is constructor is called. Okay. And now I'm creating one object student. Okay. Now see, here I just created my class, and within this I'm just creating my constructor, and here I'm printing just one statement, constructor is called, and I'm creating my object. And if I execute this one, now see, I did not call my init constructor anywhere, right? I did not call it anywhere. Now if I execute this one, now see, constructor is called. That means whenever we are creating my object and executing my code, automatically the constructor gets created, and all the function, whatever it is mentioned inside my constructor, that gets executed. Now in this case, as I'm mentioning one print statement, that is why this only printing the statement. Okay, that means whenever we are creating our object, automatically this constructor gets created and automatically gets executed. Okay, and as this is only, I'm passing my self parameter, only single self parameter, so this is called default constructor. Okay, this is my default constructor, because here I did not pass any kind of parameter except self. Self is the default parameter. Okay, so once only self parameter is there, then it is called default constructor, and once we pass our parameter in this constructor, then it is called parameterized constructor. Okay, so this is my default constructor. Now if I want to add some data over here, so we can write like this: name equal to same. Okay, s1 dot marks equal to 85. Okay, in the same way we can create any number of student. Okay, like this, s2, s3, like this, right? So for the time being, I'm just getting s2. Okay, now if I execute, okay, let me print s1 dot name comma s1 dot marks, and I can print s2 dot name and s2 dot marks. Now if I execute, then first of all my constructor gets called, and my s1 and s2 gets printed. Okay, now this is how we can create as many as student we want. We can create it, but this is the hectic work. So instead of doing that, what we can do, we can pass our parameter over here. Okay, now suppose we are passing my parameter, that is name, and another is marks. Okay, now here we can write self dot name, that is name. Okay, and we can pass self dot marks equal to marks. Okay, now instead of writing all these things, instead of writing all this data manually one by one, what we can do, we can just pass our data inside this student. Okay, Now here I'm passing my SAM, marks is 85. Here I'm passing as allies and 70. In the same way, we can print as many as we want. S3, S4, S5, S6, like this. Okay? Okay. Now, if I print, now if I execute this one, now see, it is giving me the same output. Okay? It is giving me the same output. So basically, we just minimize our code. We just simplify our code. Instead of writing our data again and again, we just parameterized our constructor. And we mention our parameter, is name and marks. And we were creating self.name and self.marks. And when we were creating our object, we just passing our data inside my class, whenever we are calling it. Okay? And just executing this one. Okay? And it is giving me all the same code. It is giving me all the same output. Okay? So this is how we can simplify our code. And as we have mentioned our parameter over here, so this is called parameterized constructor. Okay? Here one thing I need to mention, just remember, don't be confused on this name, this name, this name. Okay? Like this marks or this marks. Okay? See, this is my parameter. Okay? So this is the parameter. Okay? These two are parameter. But this self.name, this is my object attributes. Okay? So if I give any kind of name over here, that is okay. Okay? But this name is this name. Okay? These both are same. This is my parameter. Okay? This is my parameter. So if I mention self.abc and here if I mention self.xyz, then it won't be any matter. Just we have to change over here. s1.abc and s1.xyz, xyz, and here also I have to write xyz and here abc. Okay? Now if I execute, now it gives me the same output. Okay? So don't be confused. Here we can mention anything. I can mention anything because this is my object attribute. Okay? But here I have to mention whatever I passed in my parameter. Okay? So this and this are the same. Okay? So to get the more clarity on it, let's create another example. Okay? Let's create another class. Suppose employee. Okay? Now I am creating my constructor. And in this constructor, I am passing name, okay, and salary. Now I have to mention self.name. Okay, you can mention anything over here, abc, xyz, anything over here. Okay, I just write self.name, and here I have to mention the same parameter that I have passed. Okay, that is name. Okay. Now here I have to pass my self.salary equal to salary. Okay. Now my class is ready and constructor is ready. Now I am creating my object, that is E1. I am calling my class employed. And within this, I am passing my data directly. Okay. Suppose employee name allies and salary is $50,000. Okay. Now I am creating another employee, that is object E2. And we are calling employee and I am passing my data. Okay. Suppose Bob. And the salary is $60,000. Okay. Now, if I print E1 dot name, comma E1 dot salary, in the same way, I can print E2 dot name, comma E2 dot salary. Okay. Now if I execute this one, okay, let me comment it out. Okay. Now if I execute this one, now see, Alice, the first one, E1, that is Alice $50,000, and the E2, that is Bob and $60,000. Okay. You understand? These are our constructor works. Okay. Now let's move to the next one, that is let's create one class where method and constructor works together. Okay. That means in this same example, we will create one constructor while where we will pass our all the parameter. Okay. And instead of writing our print statement like this, we will create another method, and within this we'll write all the print statement, and we will execute all our print statement by calling that method. Okay. So that is why that is how our constructor and method works together. Okay. Now let's see. Now I'm creating the same example. I'm taking the same example. Okay. Now this is my constructor is ready. Okay. Now I'm creating one method, that is show. Okay. And here I have to pass myself. Okay. Now here I am creating my print statement, that is print name self dot name. Okay. And here I am printing salary self dot salary. Okay. Now I don't need to write this print statement. Now here I have to call my method, that is e1 dot show, right? And again I have to write e2 dot show. Okay. Now understand what happens. Here I am creating my class. Now I am creating my constructor. Here the constructor initializes the data. Okay, that is name salary. It is this constructor is initializing this data, and this method, that is show, this method uses that data. Okay, that's self.name self.salary to print all the output. Okay, so our constructor initializing all the data, and this method using that data. Okay, and when I'm calling our method, it is automatically printing our output. Okay. Now see, if I execute this one, now see, Alice, name Alice, salary $50,000. This is for E1, and this is for E2. Name Bob and salary 6,000. Okay. So instead of writing this print statement, we just include everything inside my method. Okay. And we are initializing our data inside our constructor, and this method automatically uses that data. Okay. Now let's get an example. Okay. Now I'm creating another class, that is product. See guys, each time I am writing multiple examples because I want you to give more clear picture on each topic, because as much as you practice or as much as you see different type of examples, your concept will be more clear. Okay. So watch all the examples very carefully and try to practice by yourself, and that will help you to clear all your concepts. Okay. So this is my class product. Now I am creating my constructor. Here I am passing self and name and price. Okay. Now self dot name equal to name, self dot price equal to price. Okay. Now I have to create my method, def display. Here I have to mention my self parameter. Okay. Now I'm printing name self dot name, and here print price self dot price. Okay, so my constructor and method are ready. Now I am creating my object. First one is P1, okay, and that is product, and here I am passing my data. First one is laptop, price is $55,000, okay, and another is P2, here product, I am passing my data, that is mouse, and that is $50. Okay, now I need to call my method, so I need to write P1 dot display and P2 dot display, right? Okay, now let me comment it down. Okay, now if I execute this one, now see, this is the P1, that is laptop and $55,000. Okay, and this is the P2, that is mouse and $50. Okay, so this is another example where our constructor and method works together. Okay, so always remember, a constructor in Python is a special method written as underscore init. Okay, using underscore init that runs automatically whenever an object is created. Okay, its main purpose is to initialize object data in a clean and organized way instead of creating an object first and then assigning value. Okay, like this. Okay, like this. Okay, basically we are creating our object first, then assigning our value separately. Okay, so instead of doing that, we can pass values during object creation itself. Okay, when we are creating our object, we are passing our values directly. Okay, so this makes our code more professional and readable and scalable. Okay, that is why we need to use our constructor. Okay, next is, what is instance variable? Instance variables are a variable that belongs to a specific object. Okay, that means each object gets its own separate copy. Okay, values can be different for different object. Now see, if we write like this, class student. Okay, now I'm defining my constructor. Here I'm mentioning name, two parameter, name and marks. Okay, now here I am mentioning self dot name equal to name and self dot marks equal to marks. Right, now I have to define my object, that is S1, suppose S1. Now I'm calling my function, I'm calling my class, and here I'm passing my data. Okay, suppose Sam 85. Okay, like this, S2 student Bob 75. Okay, now if I print S1 dot name, then it will give me the answer as Sam, right? And if I write print S2 dot name, then it will give me answer as Bob, right? Now here this self dot name and self dot means, okay, these are called instance variable. Okay, this self dot name and self dot marks called instance variable. Why? See, when I execute this one, now S1 dot name gives me output as Sam, and S2 dot name, that gives me output as Bob. That means in both case my variable is same, name. Okay, right, my variable is same, but it has different value with different object. When I'm passing S1 dot name, it is giving me its value, and when I'm passing S2 dot name, then it is giving me its own value. That means my variable is same, but it has different value with different object. That means this variable is specific object specific variable, right? And this variable belongs to the object. That is why it is called instance variable. Instance means object. Okay, that means it is object specific variable. That means it is instance specific variable, and that is why it is called instance variable. Okay, always remember instance variable belongs to object. That means it is object specific variable and it has different value with different object. Okay, apart from that, always remember instance variable not only created within this constructor, it can be created outside our constructor. Okay, now for example, if we write class student, I'm just putting pass. Okay, now I'm creating my object student. Okay, now if I write s1.name equal to Sam, and if I print s1.name, then it will give me answer as Sam, right? Now this time this name is belong to this specific object, right? Now this name is called instance variable. Now I am creating this variable outside my constructor, right? But as this belong to this object, that is why it is called instance variable. That means we can create instance variable within our constructor and even outside our constructor as well. Okay. So this is one of the interview specific question that may be asked, that instance variable can be created outside the constructor or not. Okay. So always remember this one. Next is, what is instant method? Instant methods are methods that work with instance variable. Okay. Just remember, it is work with instance variable and it belongs to object. That means if we create class student, okay, and now I'm defining my constructor. Here I'm just mentioning one parameter, okay, name, and I'm mentioning self.name equal to name. Okay, now I've already shown you in my previous example, we can work with constructor and method together. Okay, so now if I write now one method, that is show, okay, self, and here I write print self.name. Okay, now I'm creating my object s1 student. Okay, here I'm passing my value, that is same. Okay, now I'm calling my method s1.show. Okay, so it will give me answer as same, right? I have already shown you this example, right, in practical. Now see, now this method show, this method is working with self.name. My self.name is what? This is instance variable, right? This self.name is in my instance variable. Now this show method, this method is working with self.name, right? That is why this show method is called instance method. Okay, that is what written here. Instance method are method that work with instance variable. That means this show method is working with self.name, that is instance variable, right? And belongs to the object. So this I am calling s1.show. That means this method belongs to this object, right? That is why this method is called instance method. Those method working with instance variable and belongs to the object, those method called instance method. Okay. So first is instance variable. Okay. Now if I create one class student, now I am defining my constructor. Okay. Here I am passing variable, I am passing my parameter, that is name and marks. Okay. Now here I can write print self dot name equal to name and self dot marks equal to marks. Right. Now I am creating my object. Okay, that is s1. Now student, and here I am passing my value, that is Sam 85. Okay. Now if I print s1 dot name comma s1 dot marks. Okay, now if I execute, now it will give me the answer as Sam85, right? That means this self dot name is my instance variable because this name belongs to this object. Okay, this name variable belongs to this object. That is why it is called instance variable. Now if I create another student, now I'm creating s2. Okay, here I can mention name as Bob. Okay, mass as 75. Okay, now again I can print the same thing. s2.name, s2.marks. Okay, now if I execute, now 75 Bob 75. Okay, that means my variable is same. My variable is same, but it has different value with different object, and this name is belongs to the object. That is why it is called instance variable. Okay, it belongs to instance. Instance means object. As this is belongs to this object, that means instance. That is why it is called instance variable. Okay, those variable belongs to the object, and those variable having different value with different object, those are called instance variable, right? Okay, now next is instance method. Okay, now let me copy the same thing and now let me comment it out. Okay, now this is my constructor. Now instead of writing this print statement directly, we can call our method, right? So we can create one method now, that is suppose show. Okay, show, and self, we have to pass self, and here we have to write print self dot name comma self dot marks, right? Now to print our statement, we have to call our method s1 dot show and s2 dot show, right? And now if I execute, now it is giving me the same output. Okay, Sam 85 Bob 75. That means this method, this show method is working with all the instance variable. Self dot name and self dot marks are my instance variable. So this method is working with this instance variable, that is self dot name, self dot marks. Okay, and it is belongs to this object as well. Okay, so this show method is called instance method. Okay, so those methods are working with instance variable and belongs to the object, belongs to specific object. Those method called instance method. Okay, always remember. As in this case, this show method is working with my these two instance variable. That is why it is called instance method. Okay. So I hope you understand what is instance variable and instance method, what are the difference and how they works. Okay. Next is class variable. Okay, a class variable is a variable that is shared by all object. Okay, just remember, shared by all object of a class. Unlike instance variable different for each object. Class variable same for all object. Okay, that means if I write class student, okay, now I can define my constructor, right? Self name. Okay, now print self dot name equal to name. Now I am defining my object student and passing my value. Okay, now I am printing s1 dot name. Okay, it will give me answer as Sam. Now see, this self dot name is my instance variable, right? This is my instance variable, right? Because this variable belongs to this object, right? And whenever I create multiple student, it will have the different value with different object, right? But if I mention one variable here, suppose school equal to ABC. Okay. Now see, I am mentioning this variable inside my class but outside any method. Okay. This time this variable called class variable. Okay. Always remember, class variable, we need to mention our class variable inside our class but outside of any method. Now see, now this school variable is shared by all the object individually. Okay. And it will have the same value. Now if I suppose S2 equal to student Bob. Okay. Now print S2 dot name equal to Bob. That will be Bob, right? Now if I write print S1 dot school and print S2 dot school, now in both case our output will be same, that is ABC. Okay. As this name self.name is my instance variable and it will be different for each object, right? As it is object specific, so in different student the name is different. But as my school, this school, I have mentioned this variable outside my any method but inside my class. That is why this is called class variable, and this class variable we are calling this variable using our object. In that case, all the time my variable, my output will be same. My output will be same. That means all the class variable shared by all the object. Okay. That is what it is written here. A class variable is variable that is shared by all the object of a class. Okay. So one interview question you might be asked, that's what the difference between class variable and instance variable. Okay. So instance variable and class variable. So instance variable is object specific, and class variable is class specific, right? Object variable has different value, but in class variable always has the same value, right? Instance variable we have to mention inside method, inside any method, but class variable we have to mention it outside of any method. Okay. These are the basic difference between class variable and instance variable. Okay. Now if I consider the same example, now see, this is my instance variable. Okay. Now if I mention any variable inside my class but outside my any method, suppose school. Okay. Now ABC, right? Now if I call S1 dot school and S2 dot school and then execute. Now see, 75, and in case of S1 the school is ABC, and in case of S2 school is ABC. That means my this is self.name, self.mark, this is an instance variable. These are belongs to this object and it is different for each object, right? But as this is my class variable, okay, this school is my class variable, so it is shared by all the object and it is same for all the object. The value of this variable is same for all the object. Okay, just remember this thing. This school is my class variable and these are my instance variable. Okay, this self.name and this self.marks. Okay, so I hope you understand what is class variable and what is instance variable and what are the difference between them. Okay, now as this class variable school is belong to my class, this student, so we can call our class variable using this class as well. Okay, now if I print student dot school then it will give me the answer as ABC. Okay, that means class variable is also called by its class. Okay, now if you want to change, you want to update your class variable value, then it is also possible. Now if you want to change your class variable value outside your class, then what you can do, you can write like this: student, you have to call your class dot school. Okay, now that means student dot school means I'm accessing my class variable. Okay, now here I want to give my new name. Okay, XYZ. Okay, now if I execute this one, now see, all the school name got updated: XYZ, XYZ, XYZ. That means we can update our class variable outside our class. Okay, by calling using our class name. Okay, so based on your project requirement, if it is required to update your class variable name whenever you need, then you can update it. Okay, at any time. Okay, now if we want to update my class variable for specific object, that is also possible. That means if I want to update my school name for this student, only this S1 student, that is also possible. Now how we can do this? Now if we call S1 dot school and give my new name, that is PQR. Okay, now see, I'm just updating my school name for S1 student only. Okay, not S2 or anywhere else. I'm just updating my school name for S1 only. Okay, now see, now if I execute this one, now see, 75 PQR, Bob 75 XYZ, and this is XYZ. That means I can update my class variable for specific object as well. Okay, I just call specific object dot school, that means that class variable name, and give my new name. Okay, and it automatically update my existing value for that specific object. Okay, now this S1 school name for this S1 got updated, that is PQR. Okay, this is how we can modify our class variable in different places based on our project requirement. Okay, next is class method. Okay, class method are methods that work with class variable, not instance variable. Just like instance variable, instance method is work with instance variable. In the same way, class method work with class variable. Okay, they use @class method decorator. So to define our class method is also a method like this. Suppose show. Okay, now whenever we want to define this method as our class method, just we have to put @class method. This is a decorator. Just we have to mention this decorator before creating our method, and it automatically, this method becomes our class method. Okay, just mentioning this decorator, I can convert my method into a class method. Okay, and always remember, whenever creating our class method, instead of writing self, we have to write CLS. Okay, if you write self, then it will be wrong. Okay, always you have to write CLS. This is the little different syntax you need to remember. Okay, whenever you are creating your class method, you have to put this class method decorator, and in this method, instead of self, you have to write CLS. That's it. Okay, and basically we use class method whenever we want to update our class variable and when we don't want any object specific data. In that case, we normally use class method. Okay, now is instance method. Okay, so I'm creating one class. Okay, student. Here I'm creating one class variable, school. Okay, ABC. Right, now I'm creating one class method, and for that we have to write our decorator, that is class method. This is the decorator that always you have to mention. Okay, now I have to create my method. Okay, now I'm creating my method, that is change school. Okay, and just want to update my school name. Okay, change school, and as I told you, instead of self, we have to always write CLS. Okay, you have to write CLS, and I am mentioning one parameter, that is new name. Okay, so this change school is my instance method. Okay, now I have to write CLS just like cell. Okay, CLS dot school equal to new name. Okay, now as this method is belongs to this student class, so we can call student dot this method, that is change school, and here I can give my new name, that is XYZ. Okay, now if I print student dot school, now see, now if I execute, now see, it updated my name from ABC to XYZ. Understand? Basically, this CLS dot school modified all the classes, the class variable. Okay, it class dot school modified class variable. This class variable, that is school. Okay, from ABC to XYZ. And always remember, it affects all the object. Okay, if you create any kind of object, it will affect all the objects. Okay, as this is my class variable and this is my class method, so it will affect all the objects. Okay, you let me show you how it affects all the objects. Okay, now for that, now let me define one constructor. Okay, underscore underscore init underscore underscore, and here I have to mention my self parameter, right? And one another parameter, that is name. Okay, now I have to write self dot name equal to name, right? Now this is my class method. Okay, now I'm creating my objects, this one. Okay, student, and here I'm passing my value, that is same. Okay, in the same way I'm creating another object, student, and here I'm passing my another value, that is Bob. Okay, now I'm updating my school name. Okay, now if I print s1 dot school, s1 dot school, and I print s2 dot school, and if I now execute, now see, in both case my school name got updated. That means whenever I'm updating my class variable, whenever I'm updating my class variable using my class method, it affects all the object. Okay, s1, s2, s3, whatever object is there, it will affect all the objects. Okay, if I write s1 dot name, okay, s1 dot name, and here if I write s2 dot name, okay, s2 dot name. Now if I execute, now see, for s1 the name is same, for s2 my name is Bob, because this name, this shape dot name is my instance variable, so it is different for all the object. But as this school is my class variable, so it affects all the objects, and it is same for all the objects. Okay, so always remember, instance variable different for all the objects, but class variable is same for all the objects. Okay, now if I give you another example, okay, suppose I'm getting one class, that is employee. Okay, now my company name is suppose Jake. Okay, now I'm creating my constructor. Okay, and in this constructor I'm passing self and another parameter, that is name. Okay, now I have to write self dot name equal to name. Okay, now I have to create my class method. For that I have to put my decorator, that is class method. Okay, now I'm creating my method, that is def change company. Okay, change company, and here I have to pass my CLS, okay, not self, CLS. Okay, and new company, one parameter. Now I have to write cls dot company equal to new company, right? So my class method is also ready. Now I have to create my object. I'm creating one employee, that is E1 employee, and passing my name. Okay, example Sam. Now I'm creating another employee E2. I'm calling my employee and passing my value as Alice, suppose. Okay, all right. Now I'm updating my company name. I'm calling my class. Okay, I'm calling my class and calling my class method. Okay, and here I'm giving my new name. Okay, suppose next gen. This is my new company name. Okay, now if I print is E1 dot company and E1 dot name, and I print E2 dot company comma E2 dot name. Okay, now if I execute, now see, company name has been changed for both employee. This next gen. Okay, but name is different because my name variable is my instance variable, so it is different for all the object. But as my company name that is company, this company variable is my class variable, so it is same for all the objects. Okay, so in a nutshell, we can say class variable are shared among all the objects of a class. Okay, while instance variable are unique to each object. Just remember. Okay, and when we want to work with class level data, then we use class method. Okay, class method, which are basically defined using @class method decorator, and always use CLS as a first parameter in it. Okay, this allows us to normally modify class variable in a clean and structured way. Okay, so I hope you understand how instance variable and class variable are different to each other and how they works, and how instance method and class method are different to each other and how they works. Okay. Next is static method. A static method is a method that does not use instance data. Instance means object data. Okay, it doesn't use object data or class data and is independent of both. A static method is a method that does not depend on object, that is self, and does not depend on class, that is CLS. That means whenever we are creating any kind of static method, okay, we don't need to pass self or CLS parameter over here. Okay, we don't need to pass anything. It is completely independent. We don't need to pass any parameter over here. Works like a normal function, but is placed inside a class. So static method is completely normal function, just like normal function, but the condition is this method has to place within a class. Okay, within a class. And whenever you need to write your static method, just like class method, we have to provide a decorator, that is static method. Okay, now if I write a class student, okay, now I have to put this decorator, that is static method. Then I have to define my method name, that is method name, suppose this method name, and we have to put this parenthesis, and we don't need to pass anything over here. Okay, we don't need to pass anything over here. It is completely blank. It is completely independent. Okay, and you have to provide your logic over here. Okay, so this is how we can mention our static method, right? Why do we need to use static method? See, sometime based on our project, sometime we need to write any kind of method that has to be inside my class. But this method doesn't require any data from object or class. Okay, so basically when my method does not require any data from its object or from a class, but it has to be inside my class, then we create our static method. Okay, now for example, okay, this is my static method. Okay, now for example, I'm creating one class. Okay, math class. Okay, math calculation. Okay, now I want to create one function that only add two number. Okay, that only add two number. It doesn't require any data from object or any data from class. Okay, it is simple method. Okay, so I have to create my static method. As this doesn't require any kind of data from object or class, so it is basically our normal method, and this normal method called static method. Okay, so to create the static method, I have to put my decorator, that is static method. Okay, now I have to define my function, that is def add. Okay, I'm passing two parameters, that is a and b. I'm not passing any kind of any parameter like self or cls, right? It is independent. So in static method, we don't need to pass self or cls. Okay, just remember, I'm just for adding my two number, I'm just passing these two parameters a and b. I just want to add a and b. Okay, now I'm returning a plus b. Okay, a plus b. So my static method is ready. Okay, now I have to call my function, right? I have to call my function. As this method is belongs to this class, so I have to call my method using this class. Okay, so mathcal dot add. Okay, and here I can pass any number 5, 3. Okay, and I can print the result, right? I can print the result. Now if I execute this one, now see, I'm getting the result as 8. Okay, that means this add method inside my class. Okay, this method inside my class, but it doesn't record any data from object or class. That is why it is called static method. And to create the static method, we have to put just static method decorator. Okay, and we don't need to pass any parameter like self or cls. Okay, so any method that is present inside my class, but it doesn't require any data from object or class, that is called static method. Okay, so within my class, whenever I need to create any kind of method that doesn't require any data from others, it completely defines and it completely independent, and it holds its own logic, and we need to perform that independent logic inside my function. That time we need to create static method. Okay, now in the same way, we can create another example like class student. Okay, and here I can create one static method. Okay, static method, and this method basically is a grid method. Okay, I just want to show one grid. Okay, now see, this is my static method, so I don't need to pass anything over here, cell or cls. Okay, I'm just keeping it blank. Okay, now I'm just passing one print statement, that is welcome to school. Okay, so my method is ready. Now I have to call my method, so I have to write my class name dot method name. Okay, method name. Now if I execute, now see, welcome to school. Okay, so I'm getting output as welcome to school. That means this completely different independent method that only holds a simple print statement, and it doesn't require any, it doesn't depend on any data of object or class, anything. It is completely independent. So we have created this method as static method. Okay, great. In interview, sometimes you may be asked that comparison among static method, instant method, and class method. Okay, so always remember, instant method uses self inside this parenthesis. Okay, inside this parenthesis, instance method use self, class method use cls, and static method use none. Okay, it is completely blind. And instance method works with instance variable, class method works with class variable, and static method works completely independent. Okay, just remember these 2 or 3 points. Okay, now I give you another example where we can work with all these 3 methods all together. Okay, so let me comment it out. Okay, now I'm creating one class. Okay, suppose demo. Okay, now I'm creating one, as I need to use class method, so I have to use class variable, right? So this is my one class variable. Okay, class variable, and I'm mentioning class data. Okay, this is my class variable. Now I have to define my decorator. Okay, that is init __ self. Okay. And here I can pass one value. Right. Now self dot value equal to value. Okay. Now I'm creating my instance method. Okay. Instant method. That is the def instance method. Okay. I'm getting my instant method first. Instant method and passing my self. As this is instant method, so I have to pass my self parameter. Okay. Okay. Let me write instance method. Okay. This is my instant method. Now I'm passing myself, and here I'm passing print instance. Okay. Instance. And here I'm passing self dot value. Okay. That means this self dot value is my instance variable. Okay. This is my instance variable. This is my instant method. Okay. This is my class variable. Now I will create my class method. Okay. Class method. Okay. Now in order to create my class method, what we have to write? First of all, we have to write our decorator, that is class method. Okay. Now I have to define my function, that is method. Okay. Now I'm writing def class method. Okay. And here I have to pass CLS, as this is class method, so I have to pass CLS, not self, right? Now I'm write print class. Okay. CLS dot class variable, that is class var. Okay. This is my class method, so I need to work with class variable, that is class var, right? Okay. Now my class variable is ready. Now I have to write my static method. Okay. Static method. Now in order to write my static method, what do we have to code? We have to code our decorator, that is static method. Okay. Now I have to mention my definition, def static method, and here I don't need to pass anything, as this is my static method. I don't need to pass any parameter over here, right? Now I'm printing static method called. Okay. Now I have to create my object. Okay. Now my class is ready. My all methods are ready. Now I have to create my object, right? I create D1 and I have to call my class demo. And here I have to pass my value, right? Suppose 10, right? As I have initiated my decorator and passing my value, so I have to pass my value over here. Okay. Here. Okay. Now if I call D1 dot instance method, okay, as instant method belongs to object, so I'm calling my instant method using this object, right? Okay. Now I'm calling my class method, so it is belongs to my class. Okay, so I call my class method directly using my class name, right? Demo dot class method. Okay. And for static method, I can call using my class name, demo dot static method. Okay. Now see. Now if I execute, now see. In case of instance method, it is showing 10 because I have passed my value as 10. For class variable, it is showing class data. Okay, class data, because I have put my class variable as class data. Okay. So in my class method, I just print my class variable. So it is printing class data. Okay. And in static method, I mentioned static method is called. So it is showing static method called. Okay. So this example is very much powerful because it compares all three methods clearly. Okay. So guys, I hope you understand what is static method and how static method works and why do you need to use static method and how static method is different from instance method and class method. And I have shown you the example how this all method works together in your programming. Okay. Next is 4 pillar of OOPS. OOPS is built on 4 main concepts, that is encapsulation, abstraction, inheritance, and polymorphism. Right? Now think like this. Suppose this is your house. Okay. Now your house have 4 pillar in each corner, right? That means your entire house is depends on these 4 pillars, right? And entire your house stand on these 4 pillars. In the same way, if you consider this house as OOPS, then this OOPS completely depends on this 4 pillar, that is encapsulation, abstraction, inheritance, and polymorphism. Okay, so that means without this 4 pillar, you cannot write object-oriented programming in a proper way in real world scenario. Okay, these 4 are the main pillar to write your object-oriented programming in real world scenario. Okay, now let me give you a brief introduction about these 4 pillars. Okay, what is encapsulation? Encapsulation means wrapping. Okay, wrapping. That means, suppose, just imagine tablet, you know tablet, that is medicine tablet. Now in tablet, this tablet basically wraps all different type of medicine inside it. Okay, that means this tablet is wrapping all the medicine inside it, right? In the same way, when a class wraps all different type of data, that means variables, okay, and all different type of method inside this class, then it is called encapsulation. Okay, it is called encapsulation. That means when a class in wrapping all the data and method inside it, then it is called encapsulation. Okay, next is abstraction. Abstraction means hiding complexity. Okay, now for example, you know ATM machine, right? So there is a software that is installed behind this machine, right? So in ATM, what happened? You press the button and you get the money. Right? But in this entire scenario, in backend, there are huge mechanism, right? There is a huge mechanism that is performing behind it, right? So this entire mechanism is hide from user, right? You cannot see it, right? So when you are creating this ATM software, then you are hiding all the different type of complex mechanism from user. Okay, this hiding concept is called abstraction. Okay, this hiding all the complexity in your software is called abstraction, right? Next is inheritance. Inheritance means taking all the properties and methods from one class to another class. That is called inheritance. That means, for example, if you think like parents, okay, parent is animal, okay, and child is dog. Now this animal can sleep, right? This animal can sleep. This animal can eat, right? In the same way, dog also can sleep. Dog also can eat, right? That means this dog is child. Now this dog gets all these features from the animal. That means this child is getting all the features, all the properties from parents, right? That means this child is inheriting all the properties from its parents. In the same way, when one class have its own features, right? And there is another class. Now when this class getting all the features from this class, then it is called inheritive. That means this class is inheriting all the features from this class. Okay, that means This is the child class and this is the parent class. Now this child class is inheriting all the properties from this parent class. Okay, this is called inheritance, right? Next is polymorphism. Polymorphism means same function, but behave differently. That means, for very easy example, that is print. We have used print function in different way, right? Now, if I use this print in case of list, then it will give me one answer. If I write print of dictionary, then it will give me the output in different way, right? That means my function, in both cases, my function is same, but it is working, it is behaving differently in case of different type of data types, right? That means my function is same, but it is working, its behavior is different in different case. Okay, this is called polymorphism. Same function but behave differently. Okay. So this is the brief introduction about these 4 pillars. Now let's dive deep into each of them one by one. Okay. Why this pillar matters? Now see, when we write our programming without ops pillar, that is these 4 pillars, without these 4 pillars, now in that time our code becomes messy, duplication might be increased, hard to manage. It is very hard to manage. Okay. And when we write with this pillar, then our code becomes structured, it becomes reusable, easy to maintain and scalable. Okay. This is why we need to use these 4 pillars while writing our object-oriented programming in our real world scenario. Okay. So first is encapsulation. That is, what is encapsulation? Encapsulation means combining data, that means variable, okay, and method, that is function, together inside a single unit, that is class. Okay. Just remember, the single unit is class, and also controlling access to the data, right? So encapsulation is in one line. Encapsulation is the process of wrapping data and method together inside a class and restricting data access to some data. Okay. Now see, in our previous example, we have seen how we can combine our data, that means variable and method together, right? So if we write like this, class student. Okay. Now we can initiate our constructor, right? And we can pass one parameter, that is name. Okay. Now we can write self.name equal to name. That means this is my instance variable, right? Self.name is my instance variable. That means this is my data. Okay. Now we can define one method, that is show. Okay. Now we can write print name is my self.name, right? Now if we create any object and create our object like this, now here we can pass our value, that is Sam. Now if we write s1.show, then we'll get the output as Sam, right? That means this is my class student, and inside the student I have included my variable, that means this data, and another is method. Okay, that means function. So I have included this variable and method all together in a single class, right? We have seen already this type of example in previous video, right? So this entire process called encapsulation. Okay, that means wrapping. So this class is wrapping all the variables and all the methods together in a single class. Okay, that is called encapsulation. Okay. So this is encapsulation. Okay. Encapsulation. Now I'm creating one class. Okay. Suppose student. Now here I'm initializing my constructor. Okay. Here I'm passing self and name, and I can pass one marks, another parameter. Okay. Now I can write self.name equal to name, right? And self.marks equal to marks. Okay. Now this is my constructor this is my constructor, right? Now I need to create one method. Okay, now let's create another method. Now I'm creating def show. This is my method. Okay, and here I have to pass self. Now here I can write print name is self dot name, right? And print marks is self dot marks, right? Okay, so my constructor and method is ready, right? Now I can create my object, that is s1. Okay, now I'm calling my class, and here I'm passing my value Sam, and marks is 85. Okay, now what I can do, I can call my method by writing s1 dot show. Okay, now if I execute, now see, name is Sam, marks is 85. Okay, that means this is my constructor, and here I have passed my variables, instance variable. That means this is the data. Okay, and this is my method. So I have mentioned all my data, that is variable and method, inside a single class. Okay, inside a single class. That is called encapsulation. So this entire process is called encapsulation. That means we are wrapping all the variables and all the methods inside a single class. Okay, that is called encapsulation. Okay, there are two key parts of encapsulation. The first one is bundling. Bundling is putting data and method together in one class. The example that I have already shown you, that is called bundling. Okay, that means I have a class. Inside my class, I am wrapping my data and method. Okay, that is called bundling. Okay, that is called bundling. The next one is data hiding, restricting direct access to data. That means we need to restrict our data from direct access. Okay, for example, when I'm creating any kind of object and like this. Okay, s1 equal to student and passing my value Sam 85. Okay, now if I pass something like this, s1 dot marks equal to minus 75, then this is wrong, right? This is wrong. It will show error because this is completely invalid value, because marks cannot be in negative, right? So to handle this type of error, we need to use data handling. Okay, data hiding, right? Now there are three types of the access level of data hiding. Okay, first one is public. Public means when we write self dot name. Okay, this is public because we can access this variable from anywhere. Okay, from anywhere. Okay, so this is public. Okay, the next one is protected. Okay, so in order to write our protected data, we have to write like this: self dot single underscore name. Okay, self dot single underscore name. That means this is protected, but this variable also accessible from anywhere. But the difference is, this is the indication. Whenever you mention self dot underscore any variable name, that means you are indicating that you need to use this variable very carefully. Okay, because this is protected. Okay, but you can access it from anywhere. Okay, the third one is private. So in order to write this private access, you have to write like this: self dot underscore. That means you have to put double underscore and you have to put your variable name. Okay, that means this is our private. Now this variable cannot access. You cannot access from anywhere. Okay, it is accessible only inside my class. Okay, so it is not accessible outside my class. So this is called private. Okay, so there are these three types of access level by which we can hide our data. Okay, let me consider the same example. Okay, So this is my constructor, and here I have mentioned my variable self.name, self.marks. Okay. Now this is my public. Okay, this is my public. Okay. Now if I create my object and I'm passing my value. Okay. Now if I write s1 print s1 dot name and print s1 dot marks, then I'll get the output, right? 785. That means I can access my variable from anywhere, right? So I'm accessing my this self.name, self.marks outside my class, so I can access it from anywhere. That means this is because this is public, because this name and marks are public. That is why I can access it from anywhere. Okay. Finally, now I'm taking same example. Okay. Now in order to create my variable protected, okay, this would be protected. So in order to create my variable protected, what we have to do, I have to put a single underscore. Okay, single underscore. Now here I have to write single underscore names and underscore marks. Now if I execute, now see, I'm getting the output. Okay, that means this is my protected, but still I can access it from anywhere. But the difference is whenever you write this type of code, this type of variables with underscore, automatic your team member or other coder will understand that this is a protected variable. Okay, that means you have to take care of it and you have to handle it very carefully. Okay, because you want to make this protected. Okay, so this is basically for indication. Okay, this is for indication, right? Okay. Now next one is private. Okay, this would be private. Now in order to create my private variable, I have to write like this. I have to put double underscore. Okay, I have to put double underscore. Okay, double underscore. Now see, I created, this is my private variable. I have created it. Now I am accessing it outside of my class. Okay, now if I execute, now see, it is showing some error. Attribute error. Student object has no attribute, that is underscore name. Okay, that means this attribute is not accessible from outside of my class. Okay, because this is completely private, right? This is how we can hide or protect our data from direct access by using this public, protected and private variables. Okay, now what we can do in order to access this protected private, in order to access these private variables, what we can do, we can write something like this. S1 underscore, you have to write your class name, that is student. Okay, then you have to write double underscore name. Okay, in the same way you have to write s1 dot underscore your class name, that is student. Then you have to put double underscore marks. Okay, now if I execute, now see, you are getting the output 785. Okay, so this is how we can access your private variables. Okay, but remember, this is not the recommended way to access your private variables. This is not the recommended. This is how you can access, but this is not the recommended way. The recommended way is you have to create two methods, that is setter and getter. Okay, there are two types of methods. That is, one is setter and another is getter. That means you have to create two methods, setter method and getter method inside your class, and using this method you can access these variables, protected private variables. Okay, you cannot access this private variable directly, right? You cannot access the private variable directly to anywhere. But if you want to access this type of variable, then you have to create two methods, setter method and getter method. And inside using this method, you have to provide everything inside this method. And using this method, you can access this variable from anywhere. Okay. Now let's see how we can do this. Let me first comment it out. Now I'm creating one class. Okay. Class to data. Okay. Now I'm defining my constructor. Here I'm passing self and marks. Okay. Now self dot marks equal to marks, right? But I have to create this variable protected. Okay. So in order to create that, I have to put double underscore. Okay. Now we have to create our get method. Okay. Get method. Now suppose get marks. Okay. Now that means we want to access this value of this variable. Okay. This private variable. Now I'm creating this set variable, get method. Okay. And I'm passing self. Okay. Now I'm returning self dot underscore marks. Understand? As we cannot access this self dot underscore marks, we cannot access the variable directly. So I'm returning this self dot underscore marks inside using a method. Okay, I'm returning this value inside a method. So I can access this value using this method. Okay. So I'm creating this get method. Okay. Now I'm creating another method that is set method. Okay. Now I'm giving one name that is set marks. Okay. I'm putting self and giving one parameter that is value. Okay. Now I'm creating this method in order to update or modify our private variable. Okay. As without any method, we cannot access our private variables. So we cannot modify it as well, right? So in order to get the value, we are writing this method that is get method. And in order to modify our value of this variable, we need to create one method that is set method. Okay. That is setter method. Okay. Now I have to write if value greater than 0, then self dot underscore marks equal to value. That means if my value is greater than 0, then I'm setting this self dot marks. I'm updating the value of this variable, whatever value I'm providing over here. Okay. If not, else I want to print invalid marks. Okay. Invalid marks. Okay. So my getter method and setter method is ready. Okay. Now if I create my object S1 student, and here I can pass any value. Okay. Suppose 85. Now if I write print S1 dot get marks. Okay. Now see, now if I execute this one, now see, I'm getting 85. I'm getting the value. Okay. That means in order to get our value, whatever value I'm passing to this self underscore marks, I have to create my method, because this is private. I'm putting double underscore. That means this is private, so I cannot access it from anywhere. I need to, if I want to access it, then I have to put it in a method, and that is called getter method. Okay. Now I'm putting this value. I'm returning this value in my getter method, and when I'm calling this getter method using my object, then I'm getting the output. Okay. Fine. Now if I want to update, now I want to update my value. I want to update my marks. Okay. Then what we can do? We can call our set method. Whatever I have created is set method, right? Now in order to do that, if I write s1 dot set method, set marks. Okay, use setter method, set marks, and pass any negative value, that is invalid value. Okay, now again another value I'm passing, set marks. Okay, let me do one thing. Let me print this one first. Okay, s1 dot get marks. That means now see what is happening here. I am getting my get method using this getter method. I am getting my value, whatever it is there, that is 85. Now using this set marks, using this setter method, I am updating my value. I am updating my value. After that updating, I am again calling my getter method. That means this is the initial one. After that, I am updating my value. Then again, I am calling my value again. Okay. That means whatever updation I am creating over here, that should be reflected over here. Okay. Now see. Now if I execute, now see what happened. Now see what is happening. Now for this print s1 dot get marks, I am getting 85 because this I am calling my value using this getter method. So I am getting 85. Okay. Now I am trying to update my marks, and I am putting value as minus 50. That is invalid. So as this is invalid, as this is less than 0, so it is showing invalid marks. Okay, that is why it is showing invalid marks. Now after updating, I'm try to get my marks. Okay, using this getter method. Okay, but as this is invalid marks, so it doesn't update anything. That is why this method again giving me output as 85. Now if I write any positive number, that is valid number, and then execute. Now see, I'm getting 85 and 50. Why? Because 85 for this one, initially I'm calling my getter method for to get the marks. Okay, so initially it was 85. Now I'm using this setter method. I'm updating my value, that is 50. Okay, I'm updating my value. As this is a positive value, so it is updating my value, and then I'm getting, again I am calling my getter method to get the updated value. Again I'm calling my s1 dot get marks, and then it is showing me the update value is 50. Okay, I hope you understand. Let me describe it once again. Okay, now see what is happening. I'm creating my student class. Okay, now I'm initializing my constructor. Here I'm passing one parameter, that is marks. Now I'm creating this variable. Okay, and I'm putting underscore underscore double underscore to make this private. Okay, so this is my private variable. Now in order to access this variable, I have to create my getter method. Okay, so I have given a name as get marks. Okay, now here I am returning this value. Using this getter method, I am just accessing the value. Okay, I'm just returning this value. Right, now I'm creating one setter method. Okay, setter method. Here I'm passing one parameter, that is value. Now I'm writing that I'm giving a logic that if my value is greater than 0, then my marks should be this value, whatever I pass. That means I am to update this value. I am to update this marks using this value. Okay, but if it is not greater than 0, then it will show invalid marks. Okay, that means this is my getter method. Using this getter method, I am fetching my value of my marks, and this is my setter method. Using this setter method, I am modifying my marks. Okay, I am modifying my this variable, marks variable. Okay, now I am creating my object. Here I am passing my value as 85. Okay, now I am printing the value, whatever value is there. Okay, now if I execute till here, then it will give me the output as 85. Okay, now calling this setter method, I am updating my value. If it is negative, then it will show invalid marks. Initially, using this method, it is 85. Then I am updating this my marks, this variable, using this invalid value, so it is showing invalid marks. As this did not update anything over here, so finally when I'm again calling my getter method, then it is showing the same marks. Okay, that is 85. Now if I put any valid number and press execute, then for this one it is showing for 85. Now I'm using this setter method, I'm updating a value, that is positive value 50. So it is updated my marks variable, and again when I'm calling my getter method, when I'm calling my getter method, then it is showing me the updated value. Okay, it is showing me the updated value. This is how we can create our getter method and setter method to access our private variables. Okay. Now, let me give you another example. Okay. Let me write another example. I'm giving you multiple examples so that you can get the more clarity on it. Okay. I'm writing another class. Okay. This is bank account. Okay. Suppose bank account. This is my class. Okay. Now I'm creating my constructor. Here I'm passing self and balance. Okay. Now I'm writing self dot underscore balance equal to balance. Okay. Now my constructor is ready. Now I have to create my getter method first. Okay. Now I'm writing get value. Okay. I'm giving a method name that is get value. This is my getter method. Okay. Get balance. And here passing my self, and I'm just returning self dot underscore balance. Okay. This is my getter method. Okay. Now I'm creating my setter method. Okay. Suppose this is deposit. I'm naming as deposit. Okay. This is my setter method. Here I'm passing my self, and here passing my another parameter that is amount. Okay. Now I'm writing the logic that if amount greater than 0, then my balance should be updated, right? My balance should be updated. Then I have to write self dot underscore balance equal to, not equal to, plus equal to. That means whatever balance is there, I need to add this amount. Okay. So self dot underscore balance plus equal to amount. That means whatever balance is there, I am to add this amount with this balance. Okay. So this is my setter method. So my getter method and setter method is ready. Now I have to create my object, that is account. Suppose account. Okay. And I have to call my class bank account, and here I am passing suppose 5,000. Okay. Now if I write account dot get balance, okay, get balance, and if I print this one, now see, now if I execute this one, now see, I'm getting 5,000. Okay. I'm getting 5,000 because I'm passing my 5,000. Now using this get balance method, that means this getter method, using this getter method, I'm fetching the balance, whatever balance is there. Okay. So I'm giving the 5,000. So I'm getting 5,000 as output. Okay. Fine. Now if I want to add some value, that means I am to set some value. Okay. I have to set any value, any amount. I am to add any amount to my balance. So I have to modify this. I need to modify this variable, right? This balance variable. So in order to modify, what I have to do, we have to call our set method, right? So account dot deposit. Now suppose I am depositing 2,000. Okay. Now again I'm printing the same thing. That means after depositing, I want to get my balance again. Okay. Now if I execute, now see, it was initially 5,000 because here I'm getting 5,000 because it was my 5,000. Now using my setter method, I'm updating my balance. I'm depositing 2,000 rupees. Then again I'm calling my getter method. Using this, I'm getting my balance, whatever balance is there, I'm getting my updated balance. Okay. That is why it is showing 5,000 plus 2,000, that's become 7,000. Okay. So that means using my getter method, I am fetching the value of the variable, and using the setter method, I am modifying my variable value. Okay. Variable value. And then if I'm calling my getter method, then I will get the updated one. Okay. This is how setter and getter method works. And using this setter and getter method, I need to access my private variables. Okay. So guys, I hope you understand what is encapsulation, how we do bundling, how we can hide our data, how we can use different type of variables, to restrict our data, that is public, protected, and private, and how we can access these type of variables, and especially and finally how we can access our private variables using setter and getter method. Okay, I hope you all understand all these things. Next is inheritance. One class, that is child class, okay, can use properties and methods of another class, that is parents. That means one class can use properties and methods from another class, that is parent class. Okay, that means in a single line we can say inheritance allows one class to acquire all the properties and behaviors of another class. Okay, now for example, suppose parents, we have parents. Now these parents have its feature like height, like habits. Okay, now child, this child can get the same height, can have the same type of habits, right? That means this child gets all the behavior and properties from its parents. Okay, that means we can say this child inherits all the properties from its parents. Okay, this is called inheritance. Okay, now in the same way in Python, when we are creating any class, now in this class we are creating different type of variables, okay, different type of functions. Okay, now again when we are creating any class and we are using this variable and this function over here, okay, that means we are accessing all these variables and all this function in this class. That means this class is inheriting all the features from this class. Okay, that means this is a child class and this child class inheriting all the features from this parent class. Okay, this is called inheritance in Python. Okay, now what is the syntax of writing this inheritance? Now suppose I am creating one class. Okay, this is my parent class. Okay, this is my parent class. Now here I have to provide all different type of properties. Okay, that means we can write variables, we can mention different type of variables and methods. Okay, I'm mentioning all this in this class. Now again I'm creating another class, that is child. Okay, child. Now as this child class is inheriting all the properties from this parent class, so I have to write like this. I have to put a parenthesis, and here I have to write my parent class. Understand? I have to create my parent class first, then I have to provide all the variables, method, whatever I need to put it over here, I can put it. Now when I'm creating my child class, I have to provide my child class name, and I have to put a parenthesis, and within this parenthesis I have to put my parent class name. Okay, now that means this child class is inheriting all the properties of this parent class. Okay, now here you can define any new variables, methods, plus inherited properties. Inherited properties. Okay, that means in this class I can use these inherited properties, whatever properties my parent class had. Okay, and along with it I can define my own variables and methods separately. Okay, this is the basic syntax of writing inheritance. Okay, so this is inheritance. Okay, inheritance. Now I am creating one class. Okay, that is animal. Okay, now there is a property of this animal that it can eat. Okay, now I'm creating one definition, that is eat. Okay, this is the property. Okay, animal is eating. Okay, that means this is my animal class. Okay, now this class has this feature, that is eat method. Okay, and here I'm just printing animal is eating. Okay, now I'm creating my child class. This is my animal, is my parent class. Okay, now I'm creating my another class, that is child class, that is dog. Okay, now dog is also having the same feature that this animal have, because this is my parent. This is my parent class and this is my child class. So child class should have all the features of this parent class, right? So in order to inherit all the features of this parent class, we have to put parentheses, and within this we have to pass my parent class name, that is animal. Okay. Now I'm just putting pass right now because I'm not mentioning anything over here right now. Okay, I'm just putting pass. Now understand, this is my animal is my parent class. Now this parent class has these features. Okay, this method. Okay, using this method, I'm just printing animal is eating. Okay, now I'm getting another class, that is child class. Now this child class should have all the features that its parent class has. Okay, now in order to inherit all the features of this parent class, we just need to put a parenthesis after writing the child class name. We have to put a parenthesis, and within this parenthesis I have to pass my parent class name. That's it. Now mentioning this, what happens? Mentioning this child class automatically inherits all the features of this animal class, that is parent class. Okay. Now if I create my object, okay, dog1. Now I am creating my object using this child class. Okay, this child class, right? Now using this object, whatever object I am creating using this child class, I am accessing the feature of parent class, that is int. Okay, as my child class inheriting all the features of my parent class, so automatically when I'm creating one object from this child class, I can access all the features that my parent class has. Automatically I can access all these things using my object that is created by my child class. Okay, because all the features has automatically inherit to this child class. So when I'm creating object using this child class, so I can call my all the method, all the features, whatever is it in my parent class. Okay. Now if I execute, now see, animal is sitting. Okay, you understand? This method, eat method, I have mentioned this eat method within my parent class. But as I have mentioned my parent class in this child class, I am inheriting all the features of this parent class in this child class. So I can access all the features using the object that is created from a child class. Okay, I can access it. Okay, so this is called inheritance. This is how this child class is inheriting all the features of parent class. Okay. Now in my second example, if I want to put some data, as I told you, my child class also my child class is inheriting all the features from parent class. At the same time, it can have its own logic as well. Okay, that means variable, method, anything you can mention over here. Okay, now if I put some data over here, now let me write its own method. Okay, its own method, suppose bark. Okay, now I am writing print dog is barking. Okay, that means this it is pertaining to my parent class, and this bark is pertaining to my child class. Okay, but this, as my child class is inheriting all the properties from my parent class, so I can access all the properties from my parent class as well as my own class. Okay, now if I write like this, dog 1 dot bark. Okay, because this bark is its own property, so I can call it like this. Okay, now if I execute, now see, animal is eating, dog is barking. Okay, so this is how our child class can inherit all the properties of parent class, and here I can use my own data and inherited data all together. Okay, so let me give you another example. Okay, suppose I'm creating one class person. Okay, I'm creating, this is my parent class. Okay, now here I'm creating one method, speak. Okay, that means person can speak, right? Person can speak. Now I'm write print person can speak. Okay, this is my parent class. Now this person is my parent class. Now I'm creating my child class, that is student. Okay. Now see, person can also speak, person can speak, and student also can speak. Now see, this is the advantage of inheritance. As person can speak, so I am providing this method. So student can also speak. So logically, I need to mention this definition, this method again over here, right? But this repeats my code again and again. In order to reduce the repetition of the code, what we can do? We can inherit the features. All the features. We can inherit all the features of this class, that is parent class. We can inherit all this class by mentioning my parent's class name over here. Okay. Now see, now we don't need to write this method again. Automatically, when I'm passing my parent class within my child class, automatically this features is accessible by this class. Okay. So I don't need to write it again. Okay. This is the advantage of inheritance. Now see, this class automatically get accessed. Okay. Because this is inherited. Now I can define another one definition for this student class. Okay. Now I can write depth study now I'm passing self, and here I'm writing print student is studying. Okay. Now I'm creating my object S1. I'm creating my object from this child class. Okay. Now see, now this object can access this method because this method belongs to this student class. So it can access, this object can access this class. At the same time, this object can also access this class as well, because this student class is inheriting all the properties of this person class. Okay. So if I write S1 dot study, that is also accessible because this is belongs to student, and we can write S1 dot speak. This is also accessible because this student class is inheriting the properties of this person class. Okay. So this is also accessible. Okay. Now if I execute, now see, student is studying, person can speak. Okay. You understand how our child class is inheriting all the properties of parent class? Okay. Types of inheritance. Single inheritance. When one child class inherits from one parent class, it is called single inheritance. That means I have one parent class, okay, and I have one child class. Okay. Now this child class is inheriting all the properties of this parent class. Okay. So this is called single inheritance. Okay. Here one parent class is there and one child class is there. That is called single inheritance. Okay. Multiple inheritance. When one child class inherits from more than one parent's class, it is called multiple inheritance. That means I have more than one parent class. This is one parent class, this is P2, this is P3, and so on. Okay. There are multiple parent class, and I have only one child class. Now this child class inheriting all the properties from all the parents. Okay. When one single child class is inheriting all the properties from multiple parent class, that is more than one parent class, that is called multiple. Okay. That is called multiple inheritance. Okay. Multi-level inheritance. When a class inherits from a class and another class inherits from that class, is called multiple inheritance. That means, suppose this is my parent class. Okay. Now here my child class. Now this child class is inheriting all the properties from this parent class. Now here another class. Okay. That is child class 2. Might be you can think like this. This is my grandpa. Okay. Grandpa. This is my father. Okay. And this is me. That is child. Okay. Like this. So this father is inheriting all the properties from this grandfather, grandpa, and this child is inheriting all the properties from this father. Okay, so this is called multi-level. Okay, multi-level. Hierarchical inheritance. When multiple child classes inherits from a single parent class, it is called hierarchical inheritance. That means I have one parent class. Now from this parent class, this child class 1, child class 2, child class 3, and so on. Okay. Now when there is only single parent class and multiple child class, and all the child class is inheriting all the properties from a single parent class, that is called hierarchical inheritance. Okay. First is single inheritance. Okay. Single inheritance. I am creating one class animal. Okay. One properties. I'm getting one properties, that is eat method. Print animal is eating. I'm creating another class dog. Okay, this is my child class, and I'm inheriting all the properties from my parent class, that is animal. Okay. Now here I'm creating another method, that is birth. Okay. Dog is barking. I'm creating object D1. Okay. I'm creating this object from my child class dog. Now I can access the method from my parent class because this dog is inheriting the properties from this parent class. So I can access, and I can access my own method, that is bark. Okay. Animal is eating, dog is barking. Okay. Now my code is executing properly. Now see, now here I have only one parent class and I have only one single child class. Okay. So this is called single inheritance because here I have only single parents and single child. Okay. This is called single inheritance. Okay. Okay. Now let me comment it out. Now next is multiple inheritance. Okay. Multiple inheritance. That means I have multiple, that is more than one parent, and I have only single child. Okay. Now I'm creating one class, that is father. Okay. Now I'm creating one properties of father, that is skill. Okay. Skills. Now I am printing father gardening. Okay. Father gardening. Okay. This is my parent class 1, that is father. Now I'm creating my another parent class, that is mother. Okay. I'm creating another method, post talent. Okay. Now here I'm just write print mother painting. Okay. That means this father is my parent class 1, mother is my parent class 2. Father has this skill, that is gardening, and mother has this talent, that is painting. Okay. So these are my two parent class. Now I'm creating my child class. Okay. Child class. Child. Okay. Now this child class is inheriting all the properties from father and mother both. Right. So in order to access all the features from both parent class, I need to pass all the parent class name, that is father, comma, mother. Okay. Anyways, how many parents is there? You can pass all the name one by one, separated by comma. Okay. Now that means this is my child class, and this child class is inheriting all the properties from father and mother. Okay. Now I'm just pass. I'm just putting pass. Okay. I'm not mentioning anything over here. Now I can create my object from my child class. Right. Now this, as this child class is inheriting properties from father and mother, so it can access all the methods, that is skills and talents, right? So I can write C1 dot skills, okay, and C1 dot talents. Okay. Now if I execute, now see, father gardening, mother painting. Okay. So I'm getting the output correctly. Okay. That means here I have more than one parent class. I have more than one parent class, that's father and mother. Okay. And I have only single child class. That is why it is called multiple inheritance, where I have more than one parent class and only single child class. Okay. Let me comment it out. Okay. Next is multi-level inheritance. Okay. Multi-level inheritance means one class is inheriting all the properties from another class, and another class is inheriting all the properties from that class. Okay. That is multi-level. Okay. So I'm writing one class animal. Okay. Animal. This is my parent class. Okay. Now I'm creating it. Okay. Self. Animal is eating. I'm creating another class. There is my child class, that is job, and this child class is inheriting all the properties from this parent class, that is animal. So I'm passing animal over here. Okay. Now I'm creating one method, that is bark. Self. I just print dog is barking. Okay. Now I'm creating another class, puppy. Okay. Now puppy inheriting all the properties from this dog child class. Okay. That means this is my first parent class. Now dog is inheriting from this parent class, and again I'm creating another class, that is puppy. Now puppy is inheriting all the properties from this dog class. So I can pass dog. Understand? So dog, puppy is inheriting all the properties from dog. Dog is inheriting all the properties from animal. Okay. This is how multi-level inheritance works. Okay. Now I creating another method, that is whip. Okay. Whip. Self. I'm just print puppy is whipping. Okay. Now I'm creating my object from puppy. Okay. Now I can access all the properties using this object, that is p1 dot it. I can access it. Okay. I can access bark. Okay. Even I can access whip. Understand? As my puppy is inheriting all the properties from dog, so it can access bark. Okay. Now dog is inheriting properties from animal, so it can access it. So it and bark can be accessed from this object, and whip is its own method, so it can access. Okay. Now if I execute, now animal is eating, dog is barking, puppy is whipping. Okay. So my output is correct. That means this is called multi-level, where one class is inheriting from another class and another class is inheriting from that class. Okay. Fine. Now let me comment it out. Next is hierarchical inheritance. Okay. Hierarchical inheritance. Hierarchical inheritance means I have one parent class and I have multiple child class. That is more than one child class. When multiple child class is inheriting all the properties from a single parent class, then it is called hierarchical inheritance. Okay. Now I'm getting class animal. This is my parent class, single parent class. Okay. Def it self. Guys, you might be thinking why I'm writing the same code again and again. See, as much as you write the code by your own, your concept will be more clear. Okay. So I don't have any intention to make my video longer. Actually, I do prefer this practice by writing my code again and again. Okay. So that is why I'm doing this. Now I write print animal is eating. Now I'm creating one child class. Okay. That is dog. And this child class dog inheriting all the properties of its parent class, that is animal. So I'm putting animal over here. Okay. I'm creating one method, that is bird. I just print dog is barking. Okay. Now I'm creating another child class, that is cat. And this cat also inheriting all the properties from its parents, that is animal. Okay. Now I'm creating one method, that is suppose mew. Okay. I just write print cat is mewing. Okay. Cat is mewing. Now I'm creating one object from my dog child class. Okay. And I'm creating another object from my cat child class. Okay. These two are my child class. So I'm creating two objects from both child class. Okay. Now I can write d1 dot eat. Okay. And d1 dot birth. That means my d1 is my object from this child class. That means d1 can access its own method, that is birth. Okay. That is birth. And also d1 can also access the method, that is eat, from his parent class, because this dog is inheriting properties from his parent class. Okay. In the same way, c1 can also access it from his parent class, and c1 can access mu from its own class. Okay. Now if I execute, now see, animal is eating, dog is barking. This is for this one. Okay. And animal is eating, cat is mewing for this one. Right. You understand? Here I have a single parent class and I have more than one child class, and all the child class inheriting all the properties from a single parent class. This is called hierarchical inheritance. Okay. So always remember, single inheritance is one parent class, one child class. Multiple inheritance is multiple parent class, one child class. Multi-level inheritance is like chain. Okay. Grandparents, parents, then child, all these things. This type of chains. chain. Okay, this is called multi-level, and hierarchical is one parent class and multiple children class. Okay, so I hope you understand what are the different type of inheritance we have and how they works. Okay, next is method overriding. Method overriding is a concept where a child class provides its own implementation, okay, of a method that is already defined in a parent's class. Okay, now for example, suppose parents can cook a recipe. Okay, now this child can also cook this same recipe, but adding some extra flavor. Okay, that means in both case my recipe is same. Recipe is same, but style style is different. Okay, that means in both case my recipe is same, but style is different. That means my child is overriding the same recipe which is present in parents by overriding its own flavor. Okay, so in programming language, what we can say, suppose this is my class, parent class. Okay, this is my parent class. Now here I am defining one method, suppose show. Okay, now I'm just here printing A, B, C. Okay, now I'm creating my child class. Okay, my child class. This is my child class. Now here I'm inheriting my properties from my parent class. Right? Now I'm creating the same method. Show. Always remember, in case of overriding, you have to write the same method name. Whatever you write in parents class, the same method name you have to use. Okay. So I'm writing the same method name, show self. Now I'm printing X, Y, Z. Okay. Now if I create one object C1 from this child class, okay, and if I write C1 dot show, now it will give me the answer as X, Y, Z, not ABC. Because when I write the same method and modify my printing statement, then automatically my child class override the method. Whatever method is present in the parents, my child class automatically override this parent method and update whatever I have mentioned over here. Okay, so that is why when I'm calling my show method, then it is showing XYZ, not ABC, because my child class automatically it overrides all the things, everything whatever present in my parent class. Okay, that means that is what it is written here. Child class provide its own implementation. So I am implementing my own printing statement. Okay, that means child class provide its own implementation of a method that is show, that is already defined in my parent class. So this show is already defined in my parent class. So I'm just overriding by implementing my own logic. Okay, this is called method overriding. When do you need to use this overriding? When our parent class method is not perfect for our child class and we need some customized behavior, then we have to use this overriding method. Okay, method overriding. Okay, now I'm creating my parent class. Okay, animal. Now I'm creating one method that is sound. Now I just write print animal makes sound. Okay, now I'm getting my child class dog and is inheriting from animal. Okay, now I'm creating the same method. I have to provide the same name. Okay, in case of overriding, I have to provide the same name. Self. Now I'm just write print dog barks. Okay. Now I'm creating object. I'm getting object from my child class. Okay. Now I'm accessing the method. Okay. I'm just calling this method using the word. Now see. Now initially my method sound is animal make sound. Now in dog class, in my child class, I'm just mentioning the same method name and putting this statement, that is dog barks. Okay. And when I'm accessing this method using my object, then if I execute this one, now see dog barks. Okay. That means when I'm creating the same method inside my child class, then child class automatically override everything of that method that is defined in my parent class. Okay. That means when I'm just creating this sound method inside my child class, then this animal makes sound. This replaced by dog barks. Okay. This is called override. Okay. Now if I give you another example, okay, let me comment it out. Now if I create another class vehicle, okay, is my parent class. Okay. Now I'm creating one method, that is start. And just write print vehicle start. Okay. Now I'm creating one child class. Okay. That is card. And that is inheriting everything from vehicle. Okay. Now I am creating the same method, start. Okay. Now here I just write print card starts with key. Okay. I'm creating another class bike. Okay. Now this is also inherits from vehicle. Okay. I'm creating another method, that is start. Okay. I have to provide the same name, right? Now self. Now here I just write print bike starts with kick. Okay. Now I'm creating one object from card. Okay. And I'm creating another object from bike. Okay. Now if I write c dot start, okay, and b dot start and execute. Now see, car starts with key and bike starts with kick. Okay. That means here I'm mentioning in my parents class, I'm mentioning my start method and mentioning vehicle start. But when I'm creating my child class and using the same method name, now this method gets overridden. So vehicle start gets overridden by car starts with key. Okay. And again, when I'm creating the another child class and again I'm using the same method name, then in this child class, I'm again overriding it using this line, bike starts with key. Okay. So when I'm creating my object from car and bike, when I'm calling c dot start, then it is giving me the answer this, and when I'm calling b dot start, then it is giving me answer this, because here start has, this method has been replaced by this line, and in bike this start method, this vehicle start, this line has been replaced by this one. Okay. That is why it is showing like this. Okay. So this is called override. Now see, here when I'm creating the same method, so automatically it get replaced by my own functionality here, right? Whenever I'm creating the same method inside my child class, so automatically my functionality, whatever I mentioned in my parent class, that get replaced by my own functionality, right? But in some time in my in our programming, we need to access both functionality. That means I need to access all the functionality that is present in my parent class. At the same time, I need to access all the functionality that is present in my child class. Okay. So how can we do that? That means we need to print this one and this one. When I'm calling my start method, then it will show this one and at the same time this one also. Okay, that means I want to access all the functionality from my parents class as well. Okay, so how can we do that? For doing that, we have to use a keyword, that is super keyword. Okay, there is a keyword in Python that is called super keyword. Using this super keyword, we can access our parent functionality as well. Okay, now here in my this child class, that is car, here I am using this functionality. Okay, now here I want my parent functionality as well. Okay, now to do that, what we have to do, we have to just write super keyword. Okay, super keyword, and put a parenthesis dot method name, that is start, and put a parenthesis. Okay, that's it. That means here whenever I'm writing super dot start method, that means super means I want this child class want to access the functionality from its parent class as well. Okay, that means this super keyword fetch all the functionality from its parent class. Okay, so when I'm writing super dot start, so automatically all the functionality that is present in my start method, that gets fetched in this child class along with its own functionality. Okay, now here also, if I need to access my parent class functionality, then I have to write super. Okay, and I am to access my start method. Okay, start method. That's it. Now if I execute, now previously it was showing only car starts with key and bike starts with key. Okay, vehicle start was not printing. Now if I execute, now see, vehicle start for this one, for the car. Okay, vehicle start is printing because these my parents. Now car starts with key, and for bike again my vehicle start is printing because this is my parent, and for child bike starts with key. Okay, with key it is printing. Okay, so in order to access my parents class functionality as well, in case of overriding, okay, whenever we are using overriding, then if we need to use our child class functionality only, then we can write directly. Okay, we can write directly. You don't need to pass any super keyword over here. But based on our project requirement, if I need to access my parent functionality as well, okay, then I have to use this super keyword. Okay, so the super keyword, not actually super, this super is not keyword, actually this is a function. Okay, this is a function. So super function is used to call methods from parent class inside a child class. Okay, remember, it used to call methods from parent class inside a child class. When we override a method, okay, when we override a method in our child class, the parent method is get replaced. That means whenever we use override, then this parent, whatever I mentioned in my parent class, that get replaced by its child class. Okay, but if we still want to use the parent method along with the child's method, that means if we need to access the child method function, parent method functionality and child method functionality both together, then we have to use this super function. Okay, so guys, I hope you understand what is inheritance, what are the different type of inheritance is there, how they works, what is method overriding, and how it works, and how super function works in method overriding, right? Next is polymorphism. Okay, polymorphism means one thing many forms. Okay, in simply same method name, but it is working differently. Okay, now for example, suppose there is a action that is start. Okay, this is a start action. Okay, this is a kind of method. Okay, now car can start with key, right? Bike can start with kick, right? Suppose mobile starts with button, right? That means my action is same. In each case, right? My action is same for each cases, but in different case, my action is working differently. Okay, in case of car, in case of bike, in case of mobile, my same action is working differently, right? This is called polymorphism. Okay, that means when my action, that is method, is same but it behave differently with different object, then it is called polymorphism. Okay, now for very common example, suppose we use print in everywhere, right? Suppose if we write print and we try to print any kind of list, then it will give me answer like this, right? Now if I write print and I try to print any dictionary, then it will give me the answer like this, right? And when I'm trying to print any tuple, okay, tuple, then it will give me output like this, right? That means in each case my function, that is method, is same, that is print, but it is working differently in different type of data types. Okay, that means whenever my method is same but it's working differently with different object, that is called polymorphism. Okay, so this is polymorphism. Okay, polymorphism. Now I'm creating one class. Okay, that is dog. Okay, now I'm creating one method, suppose bark, not bark, let me give name as sound. Okay, sound. Now self, now I'm just mention print dog barks. Okay, this is my one class. Now I'm creating another class, that is cat. Okay, now I'm creating the same method. Okay, I need to give the same method name, self. Now here I just print cat news. Okay, cat news. Now my class is ready. Now I have to create my object. So suppose I'm creating one object d1 from my dog class, and I'm creating another object from my cat class. Okay, now if I call my method, that is sound, d1 dot sound and c1 dot sound. Okay, and execute. Now see, dog barks, cat mew. Okay, that means my class is different. My class is different, dog and cat, and in each class I have mentioned the same method, that is sound. Okay, I mentioned the same method, sound, but in dog I am mentioning dog barks, and in cat I am mentioning cat mews. Okay, now when I'm calling my same method using my each object, then it is giving me answer as dog barks, cat meow, because it is working differently. My method is same, sound. Okay, but it is working differently with different object. When it is working with dog, that is d1, then it is giving me output as dog barks, and when it is working with cat, that is c1 object, then it is giving me output as cat mews. Okay, that is called polymorphism. When my method is same, but this method is working differently with different object. Okay, so this is called polymorphism. Now if I give another example, okay, post class years then. Okay, I am creating one method, that is fly. I'm just write print air then can fly. Okay, I'm creating another class, that is kite. Okay, now I'm creating the same method, that is fly, and here I'm just write print kite can fly. Okay, now my class is ready. Now I'm creating my object, that is k1. I'm creating object from my airplane class and another object from my kite class. Okay, now if I write k1 dot fly and k1 dot fly and then execute, then see. Now see, airplane can fly, kite can fly. Okay, that means in both case my method is same, but the actual implementation in each class is different. Okay, here I'm just printing airplane can fly, and here I'm printing kite can fly. So when I'm calling this method using this A1 object, then it is giving me output this one, and when I'm calling using this object, then it is giving me output as this one. Okay, that means my method fly is same in both cases, but it is working with different object differently. The implementation is different. Okay, my method is same, but implementation is different with different object, right? This is called polymorphism. Okay. Now let me show you one example, that is polymorphism with inheritance. Okay, polymorphism with inheritance. Okay, let me comment out all these things. Now, for example, I'm creating one class. Okay, I'm creating one class animal. Okay, this is my parent class. Okay, now I'm creating one method, that is sound. Here I'm passing cells, and I'll just write print animal make sound. Okay, make sound. Now this is my parent class. Now I'm creating one child class, that is dog. Okay, and this dog inheriting all the properties from its parent class animal. Okay, now I'm creating same method sound. Okay, cell, and here I just write print dog barks. Okay, now I'm creating another child class, that is cat, and it is also inheriting everything from its parent, that is animal. Okay, now I'm creating another method, another same method. Okay, sound, and I just write print cat muse. Okay, so my parent class and child class are ready. Now I have to create my object. Okay, I am creating object from dog class, and I'm creating another object from my cat class. Okay, now if I call my method using my object, that is d1.sound, and if I write c1.sound, now if I execute, now see dog barks, cat mews. Okay, this example is polymorphism with inheritance. Why? Because I am using all the same type of method. I'm using same method, that is sound, in each classes. So that means it is polymorphism. And inheritance is basically it is inheriting this dog and this cat. This child class are inheriting all the properties from its parent class animal. So it is inheriting, but it is overriding. So we can write this example is basically polymorphism with inheritance, which is actually method overriding. We have already learned what is method overriding in our inheritance class, right? Overriding. So this is basically example of polymorphism with inheritance, where we are using method overriding. So polymorphism is I'm using same method, and inheritance is it is inheriting all the properties from its parent class, and overriding is basically in each, whenever I'm using each different object, in each cases it is overriding its behavior. Okay, in case of dog, it is changing its behavior because initially sound was animal make sound, but when I'm using object from this dog class, then it is changing its behavior, and now it is printing dog barks. And when I'm using object from this cat class, then it is changing its behavior and overriding the output, and it is giving me output as cat mews. Okay, so basically this is the example of polymorphism with inheritance, which is basically method overriding. Okay. There is another concept in polymorphism, that is duck typing. Okay, duck typing is a concept where type of object doesn't matter. What matters is whether the object has required method or behavior. Okay, Python doesn't check what object is. That means whether object is created from parent class or child class, it doesn't matter. Python will not check all these things. Okay, only Python checks only what object can do. Okay, that means all the object has to have the same method. Okay, so this is duck typing. Okay, duck type. Now let me copy this same example. This one. So this is my same example. Now if I execute this one, now they will execute, right? Now think, suppose there are 500 of animals. Okay. Now for that, for each time I have to create different object one by one, right? One by one I have to create multiple object, and each time I have to call all the object, and I have to call using all the object, I have to call my sound method, right? So this become repeated work. Okay, so to reduce this type of issue, what we can do, we can create one function over here. Suppose def. Now I have to give one function name. Suppose I give one name as make sound, and here I have to pass any kind of name. Suppose obj. Okay, now I have to write obj dot sound. Okay, I just have to pass the method name. Okay, I just have to pass my method name. That's it. Now what you can do, instead of writing all these things one by one, I just call my function, that is make sound, and within this I have to pass my object, and I can directly pass like this, and we can call our class directly over here. Okay, dog, and again make sound, and I have to just pass cat. Okay, that's it. Now if I execute, now see, same output I am getting. Okay, this is called duck typing. That means whenever my all class having the same method, okay, then I can create a separate function, and where I can use my that method name, and using this function name I can call all the methods one by one. Okay, this is called duck typing. Now to make this code more simpler, what we can do, we can create a list of animals. Okay, suppose animals, and here within a list I can pass all my classes. Okay, that is dog, okay, cat, okay, and in this way you can pass any number of classes that you have. Okay, now what you can do, we can just write a for loop. Suppose for a in animal. Okay, now I have to call my function, that is make sound. Okay, make sound, and here I have to pass this a. That means using this for loop I am iterating all the objects one by one, and I am placing everything inside this parenthesis. That means one by one all the object will be called here, and this function will be called with each objects. Okay, now if I execute, now see, you are getting the same answer, that is dog barks, cat knows, car mews. Okay, so now you can have any number of classes over here. Okay, any number of classes over here. Now you don't need to create all the objects one by one. You don't need to call your method using each object one by one. Okay, you just create all the classes, and you just create a list and create all the objects. Just pass your class name, automatically it will create our object, and you just write a for loop. Okay, you just write a for loop, and it will automatically call this function, and it will call this method. Now each object will call this sound method. Okay, and it will print one by one. Okay, so this is called duck typing. Okay, so whenever our code base is used and we want our function to reuse, okay, and when there are multiple object types, then in that case we need to use this duck typing. Okay, so guys, I hope you understand what is polymorphism, how polymorphism works with inheritance, that is basically using method hiding, and what is duck typing, and when we need to use this duck typing, and how this duck typing works. Okay. Next is abstraction. Hiding internal implementation details and showing only essential features. Okay. Abstraction means focusing on what an object does, not how it does it. Okay. Now, for example, coffee machine. Okay. Coffee machine. Here what happens? You press the button and you get the coffee, right? This basically user does. But in the backend, how temperature gets controlled, how pressure system gets controlled, how in all the internal system is getting controlled. Do you know all these things? No, you don't know all these things, right? It is completely hide from the user. Only user comes and press the button and gets the copy. But in the backend, all these things is happening. So this is called abstraction. Hiding the details. In the same way, if you go to ATM, right? You insert your card, you press your pin, and you get the money, right? You get the money. But you don't know how backend banking system okay, banking system is working. You don't know how database is working, right? Do you know all these things? No, you don't know. So basically, all these internal features hides from the user. Okay, so this hiding process is called abstraction. Okay, so when our code becomes complex and it is very difficult to use and difficult to understand, then we need to use abstraction. Okay, so using abstraction, what we can do, we can basically user sees only necessary details, complexity is hidden, and code becomes clean and maintainable. Okay, one interview question you might be asked, that is, what is the difference between encapsulation and abstraction? Okay, just tell encapsulation hides data while abstraction hides complexity. Okay, this is the main difference between encapsulation and abstraction, right? And how we can achieve our abstraction method in Python? There are two things that we need to use in order to create our abstraction. Okay, the number one is abstract class. Okay, and number two is abstract method. Okay, so using abstract class and using abstract method, we implement our abstraction in Python. Okay, and for that we have to use one ABC module. Okay, ABC module, and another module is abstract method. Okay, this is a decorator. Basically, this is a decorator. Okay, so using this module ABC and this decorator, we use abstract class and abstract method, and we can write our abstraction in our code. Okay, so this is abstraction. Okay, abstraction. Now I am creating one class. Okay, one class. Suppose this shape. Okay, now in order to create as this abstraction, and in order to create our abstraction, we have to use abstract class and abstract method. So for that we have to use one module, that is ABC module, and for that we have to import it from ABC. From ABC we have to import ABC and abstract method. Okay, now in this class I have to pass this ABC. Okay, once I pass this ABC module in this class, then this class became abstract class. Okay, now within this class I have to create a method, and I need to create a abstract method. Okay, and in order to create this abstract method, we have to use the decorator, that is abstract method. Okay, now I have to define my method. Now suppose area. Okay, I am passing cell, and I just write path. I'm not implementing any logic over here. Okay, so this shape class is my abstract class, and this area method is my abstract method. Okay, now I'm creating another class, that is rectangle. Okay, rectangle, and it inherits all the features from shape. Okay. Now I can define the same method, that is area. Okay. Here I just print area of rectangle. Okay. Now I'm creating another child class, that is circle B. And here again I'm passing shape. Okay. This is my parent class. Now here I'm defining the same method, area. Now here I just write print area of circle. Okay. Now I'm creating my object. First object is R. I'm creating this from my rectangle class and C object from my circle class. Okay. Now if I write R dot area and C dot area and let's execute. Now see, I'm getting output as area of rectangle, area of circle. Okay. That means here this shape defines the entire structure. Okay. This abstract class defines all the structure and child classes, all the child classes define the behavior basically. Okay. So same method, but its logic is different. Okay. Now you might be thinking, what's the reason of using this abstract method and abstract class, right? Suppose you are working in a team. Okay. There are 50 of members working in a same software. Okay. Now someone by mistake forget to define the method. Okay. He just put a pass. Okay. In a child class, he just put a pass. It forget to mention this same method. Okay. Now see. Now if I execute, now see, it is giving me output as type error. Can't instantiate abstract class rectangle without an implementation from the abstract method area, because this area is my abstract method. Okay. So automatically the developer gets the error. Okay. Now if you don't use all these things, okay, that means you are using now simple parent class and simple method. Okay. And you are inheriting everything and you just put a pass. Okay. You forgot to mention the method. Okay. Now if I execute, now see, I'm getting output for this one. I'm getting output for this one. I'm not getting for this one. It is not showing any kind of error. Okay. It is not showing any kind of error. So when your code base is huge and there are multiple developer, then anyone will not get any kind of error. So it will be very confusing to detect the issue, because internally internally all the programs get hampered. Okay. You are not getting any error, but your program gets conflict and it will be very difficult to debug and it will be very difficult to find it out where is the actual the issue comes from, because it is not showing any kind of error, right? Although this error is internal, but still your program will be stuck here and you will not be able to execute your code properly. Okay. So in order to overcome this type of issue, you just need to use abstraction. Okay. You just need to use abstraction. So once you use this abstraction, and now if you forget to pass the same method, whatever method you have written in your abstract method, then if you try to execute, then it will give you the error that there is a issue, that you have not used this area abstraction method. Okay, abstract method. So automatically a developer comes to know that there is a mistake. Okay, now it will be very easy to debug the code. Okay, this is why we need to use abstraction. Now if I write the same method over here, okay, this will be rectangle. Now if I execute, then I will get the same output. Okay. So it is very easy to debug our code using abstraction. Okay. Now if I show another example, okay, another real world example. Now from ABC, import ABC an abstract method. Okay, I'm creating my parent class. Okay, class payment. Okay, now I have to write ABC in order to create this class, abstract class, right? Now I have to create my abstract method. So I have to pass this decorator, that is abstract method. Now I'm creating my function, that is method. Okay, pay. Okay, cell, and here I'm passing one parameter, that is amount. Okay, now I'm just could pass. Okay, I just could pass. Now I'm creating my child class. Okay, class, suppose credit card. Okay, now I'm passing my parent class payment. Okay, here I'm creating my same definition, that is pay, same method. Okay, pay, and here I'm passing self and amount. Okay, now here I write print paid using credit card. Okay, paid using credit card, and here I just pass the amount. Okay, I'm creating another class, that is UPI. Okay, and here I'm passing my parent class, that is payment. Okay, now here I'm creating my another the same method, that is pay. Here I'm passing self and amount. Okay, here I'm just write print paid using UPI. Okay, and I'll just pass my amount. Now I need to create my object. Okay, so P1 equal to, I'm creating from credit card. Okay, credit card class, and P2 I'm creating from UPI class. Okay, now if I write P1 dot pay, and I need to pass one value, that is amount. Okay, suppose 1000, and P2 dot pay, and here also I need to pass one value, that I suppose pass 500. Okay, now if I execute, now see, I'm getting the output as paid using credit card, that is 1000, and paid using UPI, that is 500. Okay, so this is how we can implement our abstraction logic in our real world software. Okay, real world programming. So if you think what are the benefits of abstraction, just remember we basically use the abstraction for reducing our complexity, improve reliability, better maintenance, and code reusability. Okay, one small thing, guys, that I need to mention over here, always remember you never create any kind of object from your abstract class. Okay, as we have created our this object P1 P2 from our this UPI and credit card classes, in the same way we cannot create any kind of object from abstract class, that is payment. Okay, we cannot create like this A equal to payment. Okay, so this A cannot be, this A object cannot be created, because this payment is our abstract class. Okay, you can create your object from any class, but you cannot create any object from any abstract class. As we have passed our ABC module, so this payment becomes abstract class, so we cannot create any kind of object from abstract class. Just remember this one. Okay, this might be your tricky interview question. Okay, just always remember. So guys, I hope you understand what is abstraction. So abstraction is basically a concept of hiding complex implementation details and showing only the essential feature of an object. Okay, in Python, abstraction is achieved using the abstract class and abstract method. Okay, just remember. So guys, that's bring us to the end of this video. So basically, OOP is not just a concept. Okay, It is the way of thinking and designing programs. It helps us organize code in a structured way by combining data and behavior into objects, right? Making our application easier to manage and extend in real-world scenarios. But remember, understanding OOPs requires practice. Try building small projects, create your own classes, experiment with inheritance, and apply this concept in real programming. Okay? The more you practice, the more natural OOPs will feel. Fine. So, if you found this video helpful, don't forget to like, subscribe, and share with others who are learning Python. Okay? So, in my future videos, I will continue building more advanced concepts step by step. Okay? Until then, keep practicing and keep coding. Thank you.